Welcome back to my channel, Sohail this side. So this would be the second video in the multi-threading 0 to hero series. In this video, we will discuss about various concepts. So the first thing which we will discuss about is how many ways we can create threads. Right, then we will see the thread life cycle, then what are thread interrupts, and just for your understanding, all these concepts would be same in each and every language, just the way of defining or the you can say the syntax or the methods are provided by the language are different, right? So we would understand all these concepts using the code example. So without wasting time, let's get started. Right, so first thing, in how many ways we can create threads, right? So this is a kind of Java example which I have been shown here, right? So the first way is by extending the thread class, right? And the second way is by implementing the runnable interface. Now what is a thread class? Thread class is a class which is already provided by the JDK. Now runnable interface is also provided by the JDK. Both of these are in the java.lang package, java.lang package, right? Now the third way is by using the callable and future. Right, we will understand all these concepts, callable and future, executor framework, thread pool executor, much more in depth with the more advanced code examples. But just for today's class, we will understand these concepts using both by extending the thread class and by implementing the runnable interface, so that you just have you should have a feel, okay, how the thread would be created and how it looks like when we create the thread in memory, right? So you just have the feeling that okay, this thread is spinned up and how your coordination among threads are being established. Today is the basic understanding of all those things. So but later on we will cover all these concepts with in much depth, right? So I'll just show you the code example for this as well. As you have seen here, the my thread is a class, is our custom class which is extending the thread class. But let me show you on IntelliJ IDEA how it will look like, right? So it's a thread creation. So for example, this is a thread task. The first way of creating the thread is by extending the thread class. If you see here, with what is the thread class? Thread class is already provided by the Java under the java.lang package, right? Now what kind of logic or how thread know, okay, that this logic I have to execute. For that, what Java guys has done, they have provided the run method, right? In this run method, we have to write the logic which thread will execute, right? So in this run method, the logic would be written. For example, here the simple sysout statement is written, right? So this is the one way of creating the thread class, right? Now the other way of creating the thread is by implementing the runnable interface, right? Runnable interface is also provided by the Java under the Java lang package, which I already mentioned. And here also the run method is there where we write the logic which thread has to execute, right? So if you see, I have just created the simple methods just for basic understanding. For example, let's assume we want to see, okay, how we can create threads using the runnable interface. It's a very simple example. What we need to do, the thread class is already provided by the Java. In this thread class constructor, this thread class constructor also accepts the runnable interface, right? So we pass this runnable interface implementation. Now this, if you see the task we have already created, which is implementing the runnable interface. Now so we just pass the runnable interface implementation in this thread constructor, and what we do, we just call the start method on this thread class. Now with this, what would happen, the thread would be created. Thread is already created. Once you do this, thread is already created, but when you do the start method, it would the JVM would place the thread in the runnable state. I'll explain you all the life cycle, thread life cycle life cycle in some time, but just for simplicity, just understand that this is how we can create the thread, right, using the runnable interface. Now the other way of creating the thread using the extending thread method, right? So if you see here, thread task is already extending the thread class, which is already provided by the Java. So on this thread task, we are just calling the start method, right? With this start method, what would happen? The thread would be again moved to the runnable state, right? Now the what are the other things which are already provided by the Java? So the every thread has a ID and name and some metadata information, right? Now for example, if you run this example, right, if you run, let's run this example. So if you see here, what would be happening? So here if you see, the first one is the thread name 0, right? Then the thread name is thread 1, right? So these are the names which are provided by the Java internally. But what if we want to give our custom names? For example, in distributed systems or in large scale systems, what happens actually? Thread 0, thread 1, these are very custom names which would be hard to debug later on if you see any errors, right? So what usually we do, we give the thread a name. For example, there is some order processing task which is already processing the task what all or in a thread, right? So we call that thread, we can name that thread as a order processor. For example, if you see here, the thread name is order processor, right? Now the other name what we can do, similar to order processor, we can give some kind of, for example, there is a shipment service and there is a worker thread which accepts all the shipments and do the processing, right? So we can call that thread as a shipment processor, right? So this is how we can give the custom names as well. If you see here, thread constructor accepts the thread name as well, along with the runnable interface, right? We can pass the name as well. So similar to this, the thread class constructor also accepts the name. For example, I'm just extending the thread class. If you see the super in actual thread class also accepts the name. So this is how we can create the threads and we can give the custom names as well, right? Now let's see the further things, right? Now let's assume this is the main method, right? Now you do t1 dot start, thread 1 dot start, and then you do thread 2 dot start. What would happen? Let's see with respect to the operating system, because with this only you will get to know what would happen if, let's assume, one of the thread give thrown exception. What would happen to the main thread, right? So by with this visualization you will get a clear understanding what would happen. Now what would happen, as we discussed in the earlier video, last video, we discussed thread has its own stack. Now what would happen in this case? The main thread has its own stack. When it calls the start method, what it will do internally, the another thread would be started and it has its own stack. Now on this own stack, thread 1 has the run method, and on the top of run method, what all methods it would be calling internally, those stack frames will be placed. Now similar to thread 1, there is a thread 2 as well, on which stack it has the run method. Now with this diagram we can clearly see there is a separate stack for each thread, right? And main method executes separately for thread 1 and thread 2, right? Now each and every thread runs independently, so their stack does not overlap, right? Stack memory is used for method execution and removed when a method completes, right? Now as soon as, for example, thread 2 dot start or thread 2 is completed, so what would happen? The t2 dot start, so this would be removed, right? So if an exception occurs in a thread, for example, let's assume the thread 1 throws an exception, what would happen to the main thread? Would it be impacted? No, it won't be impacted, because it has its own stack, right? So just what would happen in that case? Your thread 1 would be killed or would be terminated, right? But you can avoid this condition as well if you are using the try-catch block inside a thread, right? So with this visualization you can clearly understand, okay, what would happen if exception gets thrown, or if your thread goes out of memory, right? So let's go a bit more deeper. Let's understand this synchronized keyword, why it is necessary, and where we can use it, because with this we can understand the life cycle much more better, how the thread life cycle would look like. Now for understanding this synchronized key block or synchronized feature, let's understand with the example. Let's assume you have a bank account in some bank, right? And on certain day, right, you want to withdraw some amount from the bank account, right? And you also want to have some amount from your friend, right? So your friend actually, for example, at the same time your friend wants to deposit the amount in your bank account, right? Because you were assumed that you were supposed to receive some money from your friend, right? Now at the same time you go to the ATM and you want to withdraw the amount, and at the same time your friend also want to deposit the amount in your bank account. So synchronized first of all would come in picture only when there are concurrent requests, right? So concurrent request, which we already have seen, it means it actually at the same time, right? So synchronize actually what it does, it handles the concurrent access to the shared resource. Now what is the shared resource in this case? The bank account is a shared resource in this case, right? Now what synchronized provides, synchronized ensures that only one thread can execute this synchronized block. For example, your bank account has withdraw functionality and the deposit functionality, right? So and inside it would be calling some kind of methods, right? By for withdrawing it would be doing the balance minus the amount which you are going to withdraw, and for depositing it would be calling the balance plus the deposit amount, right? So synchronized would ensure that one at a same time either the withdraw would be called or the deposit would be called. Both can't be called at the same time. Otherwise, if both would be called at the same time, there would be kind of race conditions and there would be kind of inconsistency in the data. For example, let's understand the race condition example. Now let's assume you have a bank account balance as 1000, right? Now you go to the ATM for withdrawing the amount, and your friend goes to the bank for to deposit the amount, right, at the same time. Now to depict this case, let's assume there are two threads, right, which is withdraw thread and the deposit thread. Let's assume withdraw thread representing you and the deposit thread representing your friend. Now what would happen in this case in terms of programming? Your withdraw thread has been started and your deposit thread has also been started. So if you see here, these are the timelines actually, right, on which the thread, what thread is doing what thing. Now for example, once the withdraw is started and then the deposit also started at the same time. Now what would happen? Withdraw has first, for to withdraw the amount, what needs to be done? It has to read the balance, the account balance. What it would read? As per the current value, it would read 1000. Now at the same time the deposit thread also read the same balance. What it would read? It would read the 1000. Now once both are done, at some time the withdraw thread, what it does, it just withdraws the amount at the same time. So withdraw amount, what is the withdraw request? You want to withdraw the 200 and your friend wants to deposit the 1000. So what should be the end value of the balance after both the operations? Your balance should be actually the 1800, right? But let's see how it could lead to race condition. Now it has already read the balance to 1000 and also deposit also has read the balance to 1000. Now once you withdraw 200, how much balance would be reflected? It would be 800. And since in the deposit also you have already read the balance, right? Now when you want to deposit the balance, how much amount it would be kind of the red balance, for example the 1000 plus the 1000, it would be 2000. So this is a race condition. So how we could have prevented this race condition? If at a time only withdraw or the deposit could have been done right? Not both the operations at the same time. If only one of the operation could have been performed at a same time, then we could not have seen this race condition. Let's see this also with the code example. I have prepared the code example, right? For example, there is a bank account, right? Now the bank account, initially it has a balance as 1000. Now there is a withdraw request, right? Now what it do is, the balance is greater than equal to amount. If the requested amount is greater, the balance is greater than equal to amount, then it means the withdraw request is eligible for withdrawing the amount. The what will do, the balance minus is equal to amount. That's all we need to do, right? And for the deposit, what we need to do, the balance plus amount we need to do, right? The both things we need to do. And let's assume there is a deposit thread, which we have already seen how we can create thread by extending the thread class. For simplicity, I have created this way, right? Now deposit thread is there, right? I have overridden the run method. Now in the run method, what I am writing here, the account dot deposit. What I need to do in this thread, the deposit, I have to do the deposit. Now let's assume the withdraw thread. Now what we need to do, the withdraw thread has to withdraw the amount, right? Now let's see the race condition demo, how it would be, right? So withdraw thread, I have created one thread. Now what is this? The account, this is the shared resource as we have discussed, which we need to pass, and this is the amount what I need to withdraw. And I have just given the name to this thread, that is the withdraw thread, and to deposit thread I have given the name as deposit thread. Now I have started both the threads. Just for ignore this join operations as of now. Just assume I have done this thing just to just to get the main thread wait for both the withdraw threads and the deposit threads to get completed. Just because of that, I have just performed this operation. You can ignore this operation as of now, but the main important concept is here is the withdraw thread and the bank account is not synchronized. If it would have been synchronized, then only one of the method could have been executed at the same time, right? So this is the usage of synchronized block, right? Now let's see further. Now let's see the thread lifecycle. What is the thread lifecycle, and what how the thread states gets changed from its creation till to the terminated, right? Now many of the engineers think, okay, that this is not much important, but I would say this is very very important, because let's assume you are working in an organization, right? Now in it sometimes suddenly some issue comes, okay, your application hangs, right? Or your application is not performing well. What we usually do, thread dump. Let's take thread dump or heap dump, right? So in the thread dump, if you see the thread dump, so in the thread dump you will see the thread states, right? The runnable, the waiting, the blocked, all these states are there. So if you don't have the understanding of this thread lifecycle states, it would be very difficult for you to understand the thread dump, what the thread is actually doing. So it is very important to understand the thread lifecycle. Now let's understand the thread lifecycle. Firstly, what would happen as soon as you do the new thread, right? By calling the constructor of the thread or by passing the runnable interface inside the thread constructor, the initially what would be the state for that thread? Initially the state would be new. That means it has been just created. Now as soon as you do the start method, right, you call the start method on the thread. Now where it would go, it would go on to the runnable state. Now runnable state is where, from where actually the operating system scheduler can pick up the threads to be scheduled and to be given to CPU, right? So from this only the operating system scheduler can pick up the threads and give to the CPU, right? Now after the runnable, the thread goes to the running state. Now when it goes to the running state, when actually it is running the run method, so that is when we say, okay, the thread is in the running state. Now once let's assume the thread is in running state, right? But sometimes what happens is you do the thread dot sleep. I'll explain all these concepts, but let's assume the thread dot sleep is where just to simulate some kind of condition. Sometimes what happens is actually you want to there is some kind of IO operation which is being happening, but you don't do the while loop continuously. You just give some breather, for example thread dot sleep, just to simulate, okay, by this much time you will get the response, right? So you give the thread dot sleep, or you do the wait notify methods, right? So in this case, where the thread would go into the waiting state. Now in the sleep you pass the milliseconds, right? In that case, where the thread would go into the timed waiting state. So that is the only difference between waiting and timed waiting state. Now after the running state, there are two states which we have already discussed, for example the waiting state, and the other one is the blocked state. Now what is the blocked state? For example, the synchronized, as we have seen earlier, the bank account example, right? Either the deposit could be called, or the withdraw could be called. Only one of them could be called at the same time, right? So let's assume if the deposit is being called, right? Now where the withdraw thread would go into the blocked state, right? And blocked state, from the blocked state it would again go to the runnable state as soon as the resource is available. So that is where the blocked time waiting state comes. And as soon as your run method completes, right, your code logic gets completed, the thread moves to the terminated state. Now we have seen all these methods of creating the threads by extending the thread class, by implementing the runnable interface. But the interviewer might ask you, okay, which one is the preferred way for doing for creating the threads? Okay, now you would say, okay, by implementing the runnable interface would be the preferred way. Why? Because it allows you to separate task logic from thread execution, right? You can separate the code logic. For example, here we can see the right, so the task, right? So here we have just clearly separated the code logic, but inside, if you are extending the thread class, the logic is again tightly coupled with the thread class itself, right? So with this you are decoupling the code logic, so your segregation is there, right? And there is a flexibility of passing the task to the executor service as well. We will see the executor service in the coming sections or in the coming videos, but executor service usually takes the runnable or the callable implementations, right? So it is very important that we segregate the code from the thread class. So that is where we can use the runnable interface, right? So let's understand first of all, before moving forward to the thread interrupts, I just want to show you the thread lifecycle demo, right? So I have prepared this class as well, right? Now assume this is the thread lifecycle class, right, which is extending again the thread class just for simplicity. Now when the thread would go into this run method, what would be the state? It would be the running state. Now when we'll do the thread dot sleep, right? So thread dot sleep means we are just waiting for something. This thread is just waiting for something to be performed, or something to be done, or some action to be taken, right? So just simulating this sleep, right? So the thread dot sleep, when we do this thing, where the thread would go into the timed waiting state, right? And this is the synchronized keyword which we have discussed. There are different ways where we can use synchronized keyword, but assume this is we can use synchronized keyword along with the method as well as on the block level. So this is a synchronized keyword we are using with the block level, right? So inside the synchronized keyword we can use the wait and the notify method. Now we will understand all these concepts using the wait and notify, all these concepts in much deep in the coming videos. Just to depict the thread lifecycle, I have given you this example. Now as soon as you created the thread, right, where it would go into the new state, right. Now when you do the thread dot start, it would go to the runnable state, right. Now let's run this program. You will get the better understanding for this. I'm just running this program. Now if you see, this thread 0 is the new state when it is when as soon as we created this thread, right. So initially the thread is in the new state. Now when you start the thread, it would go into the runnable state, although we cannot represent the runnable state from here, but because it's happening in a quick fashion. But as soon as you do the start method, right, so as soon as the thread run methods gets executed, what it would be the state? It would be the running state, right. Now we have given the small delay here, right, so that our thread gets moved to the timed waiting state. If where here we have given the thread dot sleep now, right. So if you do here, right, so after start, this where the thread is going to the timed wait state. So how we can get this state? There is a method inside the thread class as well, from where we can get the state. The method name is the get state, right. So with this state method, we can get the thread state, what is actually thread state is right now. Now you can see this synchronized keyword is there, right, and we have used the wait here, right, inside this. Now with this, what would happen is, now with this here also we have used the synchronized keyword. Once this is the kind of similar kind of example. Let's assume this is the withdraw, right, this is the withdraw, and this is the deposit. Let's assume this is the case, right. Now with this as well, the only one thread would get a chance to go inside it, right. Now let's assume this thread get a chance, right, that this thread get a chance, right. It would go where? It would go to the waiting state, right. And once this thread gets a chance, it would notify the thread from the waiting state, right. And finally, once this is done, the run method gets completed. So after the final, where what would be the thread state would be the terminated state. So this is the complete thread lifecycle demo which I have just prepared, right. Now thread interrupts, this is a very very important concept as well. Most of the engineers don't understand this concept, why this is required, but this is very very much required. So I'll just explain you. Let's assume this is a main thread, right, in which we have created the new thread, and by calling the start method, the another stack is being created, right, and this thread is running its own operation, right. Now what you have done, you have just created the thread. Now let's assume this thread, what it is actually doing, it is downloading some kind of large file, right, which is very very heavy large file. It's a kind of long running operation. But let's assume after some time, user changes his mind and want to cancel the download. He doesn't want to get this downloaded file again, right. So he just want to cancel this operation. No, but your thread has been started. How you can cancel this thread? How you can stop this thread, right? Because otherwise, if you don't stop this thread would consume resources, right? And just for everyone's information, there is a thread dot stop method there, right? If you there is a stop method there inside the thread, but that is not recommended way, or that is not recommended way, and that is also deprecated to be used, right? Now why it is deprecated, why it is not recommended way for that? So because first thing, it kills the thread immediately without giving it a chance to release the logs. Now let's assume you are doing some operations in the memory, right? Or you are doing some kind of shared memory you are using, and you are updating the values there. But right, so if you kill the thread immediately, right, so it would kind of doesn't give a chance to release the kind of logs. We would understand the logs in the deeper in much deep in coming videos, but it would not give a chance to release the logs, right? And also the inconsistency would be there if the thread is modifying a shared resource, for example the database, right? Now the inconsistency in the data may happen. So the better and the recommended way is you either use the interrupt, because of there is a interrupt method is also there in the thread class, right? So to stop thread 1, what we will do is we can call the interrupt method, right? Now who will call this interrupt method? The main thread would have to call this interrupt method, right? Because it is the main thread who wants to do get this operation cancelled, right? Now to stop this thread 1, main thread has to call thread 1 dot interrupt. Now there could be few more cases, right, when this interrupt method is being called, because we have seen the life cycle, right? Now the thread could be in running state, could be in waiting state, could be in blocked state, right? There are 3 cases where in which the thread would be there, right? Now when the thread would go in waiting state, as we discussed, inside the sleep, if we do the sleep or if we do the wait, right? And on the wait also sometimes it goes to the block state when we are using the synchronized keyword, right? Now with this your thread goes to the waiting and the block state. Now what the for example, when we call the interrupt method and assume our thread is in the blocked state or the waiting state. Now let's assume this is the stack frame, the under the run method, from the run method we are calling some kind of process method, right? Now when the thread would go into the waiting state, the thread would go into the waiting state or timed waiting state when we are using the sleep method, and when the thread would go into the block state when we are calling the wait method and inside the if condition, but that's also inside the synchronized block, because if you see here public synchronized is there is a synchronized keyword being placed there with which we are calling the wait method or the notify method or the sleep method, right? With this synchronized method, sometimes, for example, let's assume the other thread would also come. If one of the thread is already running this process method, the other thread won't be able to get a chance to run this method. The other thread would go into the block state, right? Now if the thread is blocked or waiting, right, on sleep, wait or notify, what interrupt would do? When you call the interrupt will immediately wake it up. Interrupt will immediately wake up the thread and immediately terminate the thread. Now inside the catch block or the finally block, what you can do, you can clean up the resources, you can do the revert of the changes if the data inconsistencies are there. So all those operations you would be performing here. That is the main reason your sleep method, the wait method or the other method provides the interruption exception, the checked interruption exception, which the developers has to forcefully catch it, right? And let's assume the other case could be if the thread is in the running state. Now if the thread is in the running state, what the thread would do to check if the thread is already interrupted, what it can do is for example, there is a long running thread, right, and there are 3 operations: operation 1, operation 2, operation 3, right? Now inside each operation, the first condition could be there that if thread is interrupted, if that thread is interrupted, just throw interrupted exception there, and in all these operations should be in the try catch block, and inside this catch block you can just do the cleaning of resources. But note, this is not guaranteed that the once your thread is in the running state, if you check the is interrupted flag as well, this is not guaranteed. This is a cooperative mechanism by the JVM, but this is not guaranteed. But yes, when your thread is in under the sleep or the waiting state or the blocked state, inside this state, this is 100% guaranteed that as soon as you interrupt the thread, as soon it would wake up the thread and it will kill the thread and throw the interrupted exception. So that's how it would be, right? Now we have seen the interrupted thing, but there is one more way how we can stop the thread. For example, the downloading the large file is there, the task we have already started, but we want to cancel that thread, right? We want to cancel that task. There is one more way to stop that thread. How we can do that? By keeping a boolean variable, inside the thread class itself. For example, this is a simple thread which we have already seen. What we need to do, we need to just create the stop flag. We just need to declare the stop flag as a false internally, initially, and inside the run condition, let's assume you are doing some kind of continuous operation, or inside the while loop. The main intent is the thread has to periodically poll this stop flag, right? Either in a while loop or in a file or in a for loop, anywhere. So the stop, it has to poll the stop variable, that whether it is marked as true. If that is marked as true, what it needs to do, it needs to break that if condition or the while condition or stop condition, whatever the condition is there, it has to stop that thread immediately. Either it has to clean the resources or whatever the kind of logic would be there, but that is the other way how we can stop this thread. Now your question could be, or the some kind of interviewers ask this question, okay, when you have interrupt, and why you would do this stop method, right? Why you would use the boolean variable? Okay, because as we already discussed, we can use interrupt only if the thread might be in waiting state or the block state, because that is where the JVM guarantees that, okay, that this thread would be waken up and would be immediately thrown an interrupted exception. But once the thread is in the running state, it is not guaranteed. So in those cases, we need to use the boolean flag if the thread is executing in a loop and can periodically check when to stop. So what we do in real things, in real world, what we need to do in real world, what we do, we use the hybrid approach, right? So we use hybrid approach. That is where you must have seen the interrupted exception also being handled, and along with the interrupted exception, there are the other ways also, kind of by introducing the stop flag or any kind of flag which can exit or terminate the thread based on some certain condition. So these are the things. And note, there is one point to note here. For example, this thread internally, let's assume calling the external service, the another network call has been made by this thread, or for example the database call is being made, right? Now if you call the interrupt method, will it stop immediately? No, it won't stop immediately, because it is a kind of blocked, but kind of waiting for that particular response. It is not actually in the thread state, not actually in the waiting state, but it is inside the running block only. It is inside the running condition, but it might go forcefully sense to the runnable state, but it can't. That is where it is can't be, you can say it is not guaranteed by the JVM, right? That interrupt is not guaranteed by the JVM. So in these cases, we need to do our custom logic, right, based on stop flag or based on some timeout condition if external service is taking much time. So we have to write those cases along, we have to handle and write those cases. So that was all I had planned to cover. So if you really like my explanation, please do hit like, subscribe, and share my channel among other friends, and see you in next video. Thanks a lot. Thanks.